Hello everyone, let's talk about cross-validation in this lecture. This is a very interesting technique. It can help us to measure the accuracy of a model in different data sets. Let's talk about it. Last time, we talked about how to use ROC to measure and compare the accuracy of models. But we are facing a problem. The issue is ROC values of a model will change in different data sets. For example, in one data set, the ROC value of a logistic regression model is better. But in another data set, the ROC value of a decision tree could be better. So when we have different data sets, how do we know which model is more accurate? We use cross-validation to answer this question. This slide shows everyone the general process of a cross-validation technique. First, similar to the previous technique, we split a dataset into training and test dataset. Then in the second step, we want to further split the training dataset into even smaller groups. For example, we can split the training set into 5 smaller groups or 10 smaller groups, or any number you like. We call each smaller group a fold, F-O-L-D. You may frequently hear people say K-fold cross-validation. K is the number of smaller groups you want to split the training data set into. In practice, we usually split the training set into 10 folds, in other words, 10 smaller groups. But as I said, you can split it into any number of smaller groups you like. Then we can move to the third step. The third step is use K-1 folds for training purpose, and then use the case fold for validation. What it means is, suppose we split the training set into 10 folds, 10 smaller groups. Then we want to use 9 of them for the training purpose to build models. For each data set, each smaller group, we can build a model, right? And then we should have 9 versions of models. Then we want to use the one that is left for validation purpose. Among the 9 versions of models, we want to use the 10th fold to measure which one has the best accuracy. By doing this, we can select the best accuracy of a model if we have multiple data sets. If you want to be more certain, you can repeat step 3 several times. Then we call this technique repeated cross-validation. After step 3, if you want to predict something, you can apply the testing data set to the model you just built and then predict the dependent variable. Step 5 is more important. No matter how many smaller groups we split in the training set, after all, they are just the samples, right? They just represent the population we are interested. So if we want to take a look at the accuracy of a model in the population, we should take a statistical perspective. What we want to do is to randomly form some samples, new samples, and then apply the model to these new samples. Take a look at the ROC of the model. Then we want to compare if a model's ROC is statistically better than another one. Which model is more accurate? This is the general process of a cross-validation. The process could be very abstract to some classmates. So I want to use an example to show you how to perform cross-validation in the R software. A researcher wants to use a person's body weight, frequency of gym visits, amount of daily sugar consumptions, the state this person resides in, and the cholesterol level to predict the risk the person has type 2 diabetes. I want to use the logistic regression and decision tree models to predict the risk. I want to build the models, and then I want to use cross-validation to select a model with better accuracy. Let's open the R software. We'll be using a dataset called the T2D records. I listed this dataset in this video's comment section. You can download it into your working directory and then follow this video. Let's create a data frame to bring the source data into the software. Let's call the data frame T2D data. Then I will be using read.table function. The source data file is called T2D records.csv. So let's type it in. Let's take a look at T2D. Let's use the head function. So this is the data set. We are more interested in the title. We are not very interested in each data record. Let's take a look at the title. We have body weight, gene visits, state, sugar intake, CH level. These are the independent, right? And then we have a T2D. If a patient has diabetes, we use 1 to indicate this disease. Otherwise, we use 0 to indicate a person doesn't have diabetes. Here I have 2 points to mention. Notice that under T2D, we use 1 to indicate a diabetes patient, 0 to indicate a healthy person. 1 and 0 are basically numerical values. If you use other packages to build logistic and decision tree models, you have no problem if you use numerical values as different groups. But if you want to perform cross-validation in the R software, we cannot use 1 or 0, those kind of numerical value, to indicate different groups. We must transform numerical values into factors. I will show everyone how to transform 1 and 0 into different factors later in this lecture. The second point I want to mention is, in this example, I used the balanced dataset. Corresponding to balanced dataset, we have an imbalanced dataset. What does the imbalanced dataset mean? That means if you have a large dataset, but the number of success cases is very small. Let's say in the loan default example, we have 10,000 customer records, but only 1 customer didn't pay back the mortgage on time. 1 out of 10,000 obviously just form a very small percentage. If we have a dataset like that, we call that dataset imbalanced dataset. So an imbalanced dataset refers to a dataset with an extreme small percentage of successes. A success refers to a case that we are interested, we want to detect or figure out. A balanced dataset doesn't have an extreme small percentage of successes. For example, in this case, we have 200 patient records. Among the 200, 61 of them have diabetes. 61 over 200 is not a small or extreme small percentage, right? So this dataset is a balanced dataset. For imbalanced dataset, we use different techniques for cross-validation. I will talk about imbalanced cross-validation in another video. In this video, we want to focus on the cross-validation for balanced data records. This is the second point I want to mention. Next, let's transform T2D 1 and 0s into factors. This is how. Here we use T2D data $T2D twice, right? The one on the right refers to 0 and 1s. And then we give 0 and 1s as values to as.factor in order to transform them into factors. And then we want to give the new values to the T2D column again. This is what this code means. So let's press enter. I want to use the levels function. The purpose of the levels script is to replace all zeros in the T2D column with no, and then replace all ones in the T2D column with yes. These two lines of scripts shows everyone how to transform numerical values into factors. Let's take a look at the transformed dataset. Let's press enter and then type in head T2D data again. Now you can see in the transformed dataset, if a patient has diabetes, then in the T2D column, he or she should have yes. Otherwise, he or she should have no. This is the data preparation process. We are ready to perform cross-validation. Several packages are available in R for cross-validation. In this lecture, I want to use a package called caret. Caret sounds like the vegetable we eat, but caret really stands for classification and regression training. So let's use this package to perform cross-validation. Let's install the package. Let's type in install.packages. And then the package name is caret, classification and regression training. And then press enter. Let's choose a mirror sign. Caret is a very large package, so we have to install several relevant packages, but R will take care of that. Okay, let's start the caret function. Let's use the library function. Let's type in library caret. Okay, we are ready to use the package. In order to randomize the data sampling, let's use a set.seed function first to randomize the samples. Let's type in set.seed parentheses. Between parentheses, you can type in any integer in order to tell the software you want to randomly form samples. Let's use 777 since it's a lucky number. Press enter. We can build the model and perform cross-validation. The first step is to split the original data set into a training set and a testing set. We use create data partition to do that. Let me give a create data partition result to a variable. Let's call this variable partition rule. We want the software to remember how many data records we want to give to the training set, how many should be given to the testing set. So we record this rule into the variable called the partition rule. And the function is called create data partition. We need to give 3 parameters to this function. The first one is according to which column we want to split the data set. In our case, the diabetes patients and the healthy patients are stored in the T2D column, right? So we want to use this column to split the data set. The second parameter is the percentage of data that should be given to the training set. It's called P. P equals to, then you can indicate the percentage. For example, if I use 0.7, then 70% of the original data set should be given to the training set. The rest will be given to the testing set. This is what P equals to 0.7 means. Here I want to mention one point. In a balanced data set, caret package uses random data partition, meaning that the percentage of successes in the training set is as same as the one in the original data set. For example, we just said in the original data we have 200 patient records. 61 of the 200 patients have diabetes. So the percentage of successes, or the percentage of having diabetes, is 61 over 200 in the original data set. 61 over 200 is 30.5%. This is the percentage of having diabetes in the original data set. Now we want to give 70% of data to the training set, right? 0.7 times 200 is 140. So in the training set, we know the total number of records is 140. In order to form the same percentage of successes as the original data set, 140 should times 30.5%. That means 43 patients in the training set should have a diabetes. So in the 61 diabetes patient pool, we should randomly draw 43 of them and then give them to the training set. How many healthy patients we should give to the training set? 140 minus 43 equals to 97. That means in the original data set, among the healthy patient pool, we should randomly draw 97 healthy patients and then give them to the training set. So in the training set, we have 43 patients with diabetes. 97 patients are healthy. You don't need to remember all of this. All of the calculations will be done by the create data partition function. You just need to tell the function the percentage of original data you want to give to the training set. Then the function is able to calculate how many healthy patients it should give to the training set, how many diabetes patients it should give to the training set. But I do want everyone to remember that in a balanced data set, the percentage of successes in the training set is as same as the one in the original data set. Next, let's give the third parameter to this function. Let's type in comma and then type in list equals to f. This means in the output, we want the output to be data frame, not list type. And then press enter. Next, let's create a variable to hold the training set. Let's call this training set. This is how we create the training set. We want to apply the partition rule we just created to the original data set. We want to type in T2D data. This is the original data frame, right? And then I want to type in brackets. And then between brackets, I want to type in partition rule. And then a comma. And then press enter. Now we give 70% of the original data set to the training set. Let's give the rest to the testing set. Let's create a variable called a testing set. And then let's type in T2D data, the original data frame, and then brackets. Between brackets, we want to type in a small dash and then partition rule, comma. This means we want to give the 70% to the training set, right? The small dash means opposite. We give the rest to the testing set. Press enter. The next step is to create smaller groups in the training set, the k-folds in the training set. We will be using a function called train control to achieve this goal. Let's give the result from train control to another variable. Let's call this split rule. We need to give several parameters to train control. So let's type them in and then I will explain. This is the function name from a caret package. It's called a train control. In this case, I will be using 5 parameters. What these parameters mean is, first, let's take a look at the number. The value of number indicates how many smaller groups we want to create in the training set. If we want to create 10 smaller groups, that means we have a training set with 10 folds, right? And then we give a value 10 to the number parameter. If you change your mind, you want to create 20 folds, then you give 20 to number parameter. If you want to create 6 folds, then you give 6 to number parameter. As we just discussed, we can repeat cross-validation several times, right? We give the number of repeats to the repeats parameter. Here I give 3. That means I want to repeat cross-validation 3 times. If you want to use repeated cross-validation, to the method parameter, you must indicate repeated CV. Then the software will know you want to repeat cross-validation 3 times. Then we have a class props. We want to use t as a value for this parameter. The reason is we want to calculate the ROC value. Those are the probabilities. That's why we want to indicate t, true, as a value for parameter class props. Then we have an optional parameter. It's called a summary function. How you want to show the final results. We want to give the value toClass summary to this parameter. This is what these parameters mean. Let's press enter. Now we can use the training set and the split rule to build some models. Currently, the caret package can build up to 260 different types of classification and regression models. In this case, I will be using decision tree model and the logistic regression model. The function for building a model is called a train, and the function for building a decision tree model is called a GBM. Let me create a variable to hold the results from the train function. Let's call this GBM model. And then I want to type in the function name train. It has several parameters. Let me type them in, and then I will explain what they mean. The first parameter is the statistical model, using which independent variables to explain which dependent variable. In this case, we want to use a person's body weight, frequency of gym visits, amount of daily sugar consumptions, state he or she resides in, and the cholesterol level to predict the risk of having diabetes, type 2 diabetes, right? Yes or no answer are stored in the T2D column. So this is the dependent variable we want to predict. That's why we list the T2D. And then a tilde sign. A tilde sign is the equal sign in the statistical equation. Here we have a dot. What does dot mean? The dot means except for the T2D column, we want to use all other columns as independent variables. Of course, you can select certain independent variables. For example, if you just want to use body weight and cholesterol level to predict the risk of having type 2 diabetes, then you can remove the dots and then replace the titles of the two columns. Let's remove the dots and then type in body weight plus cholesterol level, CH level. That means in the new model, you just want to use body weight and cholesterol level as independent variables. But in this case, we want to use all other factors as independent. So to simplify the equation, we simply type in a dot. That means except for T2D, we want to use all other columns as independent variables. This is what the first parameter means. The second parameter is data. Data equals to training set. It's very clear to everyone. This means we want to use the training data set as the source data to build the statistical model. The third parameter is called the TR control. As you can see here, we give a split rule we just created to this parameter. This tells the software how we want to perform the cross-validation. In the split rule, we just tell the software we want to create 10 folds in the training set. We want to repeat cross-validation 3 times and use the repeated CV method. By giving split rule to TR control parameter, the software is able to use the method we just built to build the model. The fourth parameter is very important. We want to tell the software which model we want to build. In caret, the decision tree model is called a GBM. So we give GBM as a value to the fourth parameter method. The fifth parameter is how we want to pre-process the data. You can copy the method I just listed here. The last parameter is very important. We want to tell the software what kind of result we want to see. As you can see, the result metric should have ROC values of each model. This is what these parameters mean. Let's press enter. Because GBM is not installed along with the caret package, we must install it. So if you want to run GBM for the first time, the software will ask you, do you want to install the GBM package into the R software? After selection, you type in 1 to indicate yes, you want to install the GBM package, and then press enter. So the GBM package will be installed. On some classmates' computers, before you install any analytical package, the R software may remind you that you missed the E1071 package. If you meet this error, simply install the E1071 package into your R software. I will list the information about the E1071 error in this video's comment section. The information on the screen above just shows how we built the training model, but it doesn't show us the performance of this model's accuracy. So I want to use the testing set to take a look at the decision tree model's accuracy. I will be using the predict function. I want to give the result from predict to another variable. Let's call this GBM test. This is the variable that holds the predict result. Predict is the function we will be using. We need to give two parameters to the predict function. The first one is the model we just built. It's a GBM model, right? And then a comma. The second parameter is called new data. Obviously, we need to give a testing set to new data, because testing set is the variable that holds the testing data set. Press enter. Next, I want to build something called a confusion matrix to show the decision tree model's accuracy. This is the function name, confusion matrix. We need to give two parameters to this function. What these two parameters mean is we want to give GBM test to the parameter data. GBM test is the variable that holds the predictive model's results, right? According to all of those independent variables, according to the model we built from the training set, we can predict which patient should have a type 2 diabetes, who shouldn't. But remember, the GBM test just holds the predicted value, forecasted value, right? We want to compare the GBM test result to the T2D column in the testing set, because in the T2D column of the testing set, we record who has diabetes, who doesn't. Then we want to see between the predicted value and the real value, how many cases we accurately predicted. This is the purpose of a confusion matrix. Let's take a look at it. You see, this is the error I just talked about. I missed the package E1071. To address this problem, I simply install this package. So let's type in install.packages. Press enter. Let's bring it back and then press enter. Now you can see the results, right? The accuracy of our model is about 0.76. This is accuracy. Next, let's use a similar process to build the logistic regression model. In caret, the name of the logistic regression model is called TLM. So let's bring back the previous comments. We want to create a TLM model. Let's change the previous models. Let's change GBM model to GLM model. And then in the method, let's change GBM to GLM. Press enter. So we get a logistic regression model done. Next, let's build the predictive model for logistic regression. Let's change GBM test to GLM test. And then in the parameter, we change GBM to GLM as well. We still use testing set. Press enter. Next, let's bring back the confusion matrix. In the new matrix, we need to use GLM test. And then press enter. So this is the results from a logistic regression model. And this is the accuracy. So if you compare the accuracy of a logistic regression to the accuracy of decision tree is more accurate, right? Because the accuracy value for decision tree is larger. But don't forget, we just compared the accuracy of the two models in a sample of 200 patients. 200 patients is just a small sample of all diabetes patients. We have to compare the accuracies of the models in the population. How can we do that? We use a function called resamples. Let's create a variable to hold the result from resamples. Let's call this resums. This is the variable. And the function name is called resamples. Between the parentheses, I want to type in list, and then another set of parentheses. Between the inner parentheses, I want to type in GBM. Notice that this GBM is in uppercase, equals to the variable that holds the decision tree model. It's a GBM model. And then a comma. Next, I want to type in GLM. Notice that GLM is also in uppercase, equals to the variable that holds the logistic regression model. It's called the GLM model. And then press enter. If you want to take a look at the result, you can use summary function. This report shows some descriptive statistics of the ROC comparisons between the two models. For example, number of resamples is 30. Why we get 30? Because in the training set, in each training set, we want to split it into 10 folds, right? We repeat the cross-validation 3 times. So 3 times 10 equals to 30 samples. And then it also shows the mean of ROC of each model. For example, in the decision tree, the mean of the ROC across different data sample, the mean is 0.81. And then in the logistic regression model, across different data sample, the mean of the ROC is 0.75. This is useful to report the analysis. But if you want to take a look at the comparison in an easier way, it's better to visualize the comparison, right? We will be using a function called treelist.par.set function. Let me type it in. Between parentheses, we want to type in caret theme. Another set of parentheses. If you see this gray window, don't panic. Just click the restore button in the upper right corner. This just means we are ready to create a chart. And then next we go back to the script window. Let's type in the last comment. It's called dot plot. Parentheses. In dot plot, we need to specify 2 parameters. The first one is the variable that holds the resamples. It's called resums, right? We just created. Next, we want to show what type of chart we want to see. Matrix equals to ROC. Now you can see the comparison of ROC between 2 models in a chart. Which one is more accurate across different data sets? Looks like GBM wins, right? The decision tree has a better accuracy in different data sets. This is how you perform cross-validation.